Hi folks, this is Professor Chuck Williams, and I'd like to welcome you to this edition of Earth Science from the Field. The subject of this video is the weathering of rock. Weathering, an important part of the rock cycle, is the process by which rocks at the Earth's surface are broken down. There are two types of weathering. Mechanical weathering is a physical breakup of rock into smaller pieces. Chemical weathering is the process by which the internal structure of a mineral is altered by the removal or addition of an element. Mechanical and chemical weathering work together to break down rock. Mechanical weathering breaks up rock into smaller pieces with more surface area on which chemical weathering can then work. Here are some examples. Mechanical weathering is caused by both physical and biological factors. Frost wedging occurs when water seeps into cracks in rock and freezes and expands, enlarging the cracks. Frost wedging is common in mountainous landscapes where freeze-thaw cycles occur. Biological activity includes the physical action of tree roots that grow in fissures, expand, and crack rock. Carbonic acid, naturally produced from carbon dioxide and rainwater, is important in chemical weathering. Carbonic acid reacts with crystals in rock, displacing ions and destroying the rock's crystalline structure. Organic acid secreted by plants and lichens can also contribute to the chemical weathering of rock. In this edition of Earth Science from the Field, we'll look for evidence of the mechanical and chemical weathering of rock and learn how these two processes work together to produce the sediments that help to form soil and more rock. Hi folks, I'm on a slope landform here in northwestern Pennsylvania, and behind me is a large piece of sandstone, a sedimentary rock. Sandstone is not an uncommon rock here in the northern Allegheny Plateau section of the Appalachian Mountains. This rock originally was a capstone on the plateau behind us, but over the eons has actually migrated down the slope through freeze-thaw cycles to come to rest here at the foot of this slope. A few things about the weathering of this rock. You'll notice a very large fissure or cleave through the top of this rock. That was likely formed by freeze-thaw action. Frost wedging, in particular, was probably the culprit behind that relatively large fissure. You'll also notice vegetation that's coming up behind the rock. That's actually growing in the fissure as well. That's an example of biological activity in the mechanical weathering of rock. If you look closer at the rock, you will notice that it's green, it's covered with mosses, it's covered with lichen. And both of those particular types of organisms can secrete organic acids that can begin the breakdown of this particular rock. It will take a long time. Chemical weathering is not something that happens overnight, but it is occurring. So, good example of mechanical weathering and chemical weathering here. Mechanical in the form of freeze-thaw action and frost wedging, and also in biological activity in terms of the tree roots growing down through the fissures, expanding and cracking the rock. And then finally, an example of organic acids being produced by mosses and lichens in the chemical breakdown of this particular rock. Also note that carbonic acid, which is produced by rainwater in conjunction with carbon dioxide, is a weak acid that will also further chemically weather this rock. So a number of different weathering factors are working on this piece of sandstone here in northwestern Pennsylvania.